So this is part one of a complete physics exam review. In this video, I'm just talking about kinematics and then also some proportionality at the end. There should be a time-stamped outline right now that you can see on the screen, so you can skip ahead if you want to focus on something particular. But the first thing I'm going to be doing is talking about the chase problem. So this is what the problem looks like. Two cars are 500 meters apart and they're driving towards each other. So car A has a velocity of 10 meters a second in the east direction, while car B is starting at rest and accelerates at 2 meters a second west. And then the question is how long before they hit each other. So I'm just going to draw a simple diagram. So this is going to be car A right here. Car A. And 10 meters a second. So its velocity, I'll say velocity A equals 10 meters a second. And then of course you also have to set directions for everything. So I will set east to positive. And now there's a distance between them, so it's going to be like 500 meters. So let's draw a line like this. 500 meters. And then there's car 2 over here. Or car B, I mean. And its velocity at the start. So velocity B is equal to 0 meters a second. But it does have an acceleration. So it is an acceleration of, what is it, 2 meters a second squared? Yeah, so 2 meters a second squared. Acceleration for B equals 2 meters a second squared. Nice, okay. And now we're going to put this into a formula. So there's two different objects, right? So they're both going to have their own little formula. So what we want to find is when they're hit the same position, right? So we can assume this one's accelerating, so it's probably going to be around like right here, right? Now at that point, we want to have the same time, so the same delta t, and then they're going to have the same position, which is so d final, position final, right? They're going to have the same position and the same time at that point. So at that point, we know that we need to find the same time or the same distance, right? So you can do either or, but I would find when they're at the same distance first and then just see what the time is. So what you're going to do for that, so let's do car A first. So car A's displacement, we're going to say we'll set the origin to right here. So we're going to set the origin to right where car A starts. So car A's displacement is going to be whatever d final is over here. So we're going to say displacement equals d final, right? Because you have to subtract the initial position, but there is no initial position. It's 0, right? Well, there is initial position, but it's 0. And then delta d, you can just use simple kinematic equations. So it's just going to be time multiplied by velocity, right? So we'll say delta t and then VA is going to equal final position. And then car B over here, so its final position is going to be the same thing, but its displacement will be a little bit different, right? Because remember, it's delta d position 1 or position 2 subtract position 1. It's di, so original position is 500 meters away from the origin. So it's going to be like delta d equals df subtract 500 meters. Right, so, and then you're just going to rearrange this because again you want the final position to be on one side, so delta d subtract 500 meters. Actually, this is plus 500 meters equals final position. And now put in delta d, so you use one of the equations. So in this case, we'll use the one where it is, like we'll use kind of this one right here. So time times velocity, and then plus 1/2 acceleration delta t squared plus 500 meters equals df. But now there's no initial speed, right? So I'll just take away this, and you will get this right here. So now notice how df and df, right? And again, these things are equal to the same thing. So we can just put these two equations together, which will get you delta t. And I'm also going to fill in the variables. So VA, that's equal to 10 meters a second, and it's in the positive direction. So I'll say 10 meters a second. And that is going to equal 1/2 times acceleration. So acceleration is 2 meters a second squared, and then it's also west, so I'll just write west here. And west is in negative, so it's negative 2 meters a second squared multiplied by 1/2, and that just becomes 1. So negative 1 meters a second squared, and delta t squared plus 500 meters. Okay, and then you just rearrange. So you're going to put everything to one side. And then I'm going to take away all these units right now, because just to make things easier. So this becomes positive when you move it to the other side, and then plus delta t, 10 delta t minus 500 equals 0. And then again, you just solve for time now, so you just use quadratic formula. So delta t equals negative 10 plus or minus. Okay, if you don't know quadratic formula, you got to make sure you remember it. I'm making it plus 4 because it would be negative 4 times negative 500, but I'm going to take out the two negatives because they just multiply together to equal positive. So okay. And now you just put this number in your calculator, and you should get two numbers, because remember it's plus and minus, so you should get 17.9 seconds. So that's positive 17.9 seconds, and then negative 27.9. And then, of course, you can't have negative time, right? So you can just take that out. So that would be your answer. And then let's say on your exam or test or whatever you're studying for, it asked the displacement for each one after that amount of time. You would just replace, like you just go to this original equation and you just replace like 17.9 multiplied 17.9, like that. You take the time and you just put the time back in, right? Let's do that really quick. So let's say, what is the displacement for, we'll say velocity A, or for car A, I mean, which is kind of like the crash site, right? What is the position, we'll say. So for this one, you would say df equals, we'll use this one because it's probably the easiest, so 17.9, and you'd want to use all the decimals. I don't have all the decimals with me, so times 10 meters a second, that's positive, and you'd get df equals about 179 meters, course east. So that is where they hit each other, which is, yeah, about like, yeah, kind of where I said, like right around here or so. Actually, maybe a little bit more, yeah, like about there. Alright, so that's all for this one. Let's move on to the next thing. So this is finding average acceleration problem. Here's the question. A billiard ball going 7 meters a second north 35 degrees east collides into a wall for 0.035 seconds. The final velocity is 5 meters a second north 42 degrees west. What is the average acceleration during the crash? So I'm just going to draw a quick little diagram what this looks like. So it's going to come in like this, and then there is a 45 or 40, what is it, 40, 35. So there's a 35 degree angle, and then it's going to accelerate when it's touching the wall, and then it's going to end up going in this direction, right, which is north 42 degrees west. So like right here, kind of like that. So if you remember how to calculate acceleration or average acceleration, it's going to be like this. So acceleration average equals v2 minus v1, and then divided by time. So we have all these variables over here, so that's no problem. But one thing, so when you're adding, so when you're doing, see this negative sign right here? So we actually want to take that away. We want to make it a positive sign. So the way we're going to do that is we're going to turn v1, instead of being positive v1, we're going to turn it to negative v1. So the way you can do that, so v1, or v1 positive, is 7 meters a second north 35 degrees east. Now negative v1 is just, so same magnitude, but now north and south are swapped, and east and west are swapped. So it becomes south 35 degrees west. And now you can look at this, and I'll just show how they're opposites. So like v1 is something like this. There's a 35 degree angle right there. Well, v1 negative, it's going down obviously. It looks something like this. 35 degrees. Right, and then, yeah, so I mean if you make a triangle right here, you can just tell like they're equal to each other, right? Because this angle right there is also 35 degrees. This angle right here is also 35 degrees if you were to make this into like a triangle like that. Anyways, so they're kind of equal to each other, but they're just in opposite directions. And that's what we want to do, because the acceleration of this is going to be, first of all, it has to turn this, like all the velocity in that direction. It has to then reverse and put it into this direction right here, right, which is west. So actually here I'll just draw. So north is positive, west, sorry, that's not west, east is positive, right? So anyways, let's do this question now. Actually, before we do that, one more thing, I'm going to draw a vector diagram showing the change of velocity. So change of velocity, that's this, v2 minus v1. So you're going to start off with doing negative v1. So negative v1, that's kind of down like this. Right, and it's south 35 degrees west, so something like this, 35 degrees. And now velocity 2, what's that? 5 meters a second north 42 degrees west. So it's going to look something like this, not as long though, like that. North 42 degrees west. There we go. And then this, yeah, so that's a 42 degree angle. So this right here is delta V. That line right there is delta V. This one is negative V1, and this is v2. Okay. So let's do the actual math behind this. So we have to separate the x and y axis from each other, right? So I'm just going to draw a little diagram here. So this is going to be x, that's going to be y, and then she'll say velocity x, velocity y. And then we're going to add the two things together to get our total change of velocity, which will then turn into acceleration by dividing. So I'm just going to make a little chart like this. And now this is going to be negative v1. This is negative v1. This is v2. So negative v1 is south 35 degrees west. So I'll just draw another sketch really quick. I'll do like one more for sketch. Sketch. Even though I already kind of drew it, but whatever. So this will look something like this. Yeah, and then 35 degrees. So in this case, cosine is going to be, sine is going to be the opposite, right? So just a little aside over here. So if this is 35, let me make this really big. So if there's a 35 degree angle right here, and then this is 7 meters a second, then this is the velocity y, velocity x. So velocity x is sine 35 times 7 meters a second, right? So sine 35, 7 meters a second. We actually have to notice as well is that this is in the negative direction, right? Because we made east positive, so this is all going to be negative. So just make that all negative. And then y, it's also negative, but now it's cosine, so cos 35 times 7. Again, also negative. And now, so the next one, v2, 5 meters a second north, 42 degrees west, so something like this. There's a 42 degree angle right there. So again, opposite is going to be x here, so sine 42, 5 meters a second. And this is also negative. And then cos is actually, this one's actually positive now. I believe, right? Yeah, positive. 42, and then 5. Okay. And now, this is v tot. So what you're going to do now is you just add these two things. So you're going to add like these two together, add those two together, add these two together, right? And then you just put in the totals. So I'm going to skip ahead and do that. Okay, so I got the total differences for these. So actually this is meters a second. This is meters a second. Okay. And then, yeah, I guess I'll just do a little sketch right now. So -7 is about right there. -2 is about right there. And now what you're going to do next, so you're going to want to do the vector components for these two. So you're going to want to put this into a single vector. And then after that, then we'll divide by time. So yeah, let's put this into a single vector. So what you're going to do is delta v total equals square root of delta Vx squared plus delta Vy squared. And I'm just going to skip ahead and I'm going to put in these two numbers. So that's x, right? Yeah, that's x, that's y. So I'll put these two things together. So I'll skip ahead. So let me just fix this, sorry. And yeah, and this will all equal to 7.6 32393215 meters a second. And this is like just the magnitude, so actually I probably shouldn't even wrote the vector in here because this is just the magnitude. Actually, yeah, sorry, let me write this in better. So this is the magnitude of the difference of velocity, so delta V tot. Yeah. Okay, and I also need a direction for this. So yeah, again, just vector components again. So I'll say tan theta equals opposite over adjacent. So actually, yeah, let me just draw another. So again, yeah, there's this one up here, but I'll draw a better one. So this is negative 3.6, comma, comma, comma. Yeah, so the dot dot dots just mean like to be continued. I don't want to write in all the numbers, right? Because I already have them up here. Dot dot dot. Actually, I'll write this as 1. Dot 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 dot. And then so there's theta right there. So opposite in this case is negative 2.01 dot 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 negative 7.3 6 dot dot dot. Okay. And then let's see, what should you get? So theta equals 15.3 degrees. Okay. And now you just put everything together, so I'll say acceleration average equals 6.632 dot 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 divided by, and I'll add in the direction after. And what was the time? 0.0035 seconds. This is meters a second up here. And then, let's see, all this should equal to 2,180. There's more decimals to that, but I'll just leave it as that. Meters a second squared. And then, what was the direction? 15.3, so that would be west 15 degrees south. There we go. And that's how you do this one. So that is acceleration average. Alright, so I'll skip right ahead to the next one. Alright, so I got a couple projectile motion questions. Here is the first one. A ball is thrown 37 degrees above the horizon at 25 meters a second. Will it clear a fence that's 30 meters away and 6 meters tall? If so, by how much? So I'm just going to do a quick little drawing here. So ball is thrown. It's going to make something like this, right? Actually, here, let me draw that better. So this is V naught right here, so 37 degrees. That's V naught. And then 30 meters away from it. So 30 meters. There's a fence up like this that is 6 meters tall. And now there's two possibilities, right? So I'll draw in blue possibility 1, where it kind of comes up like this, and then it's going to go down like that. Actually, more something like this, actually. Or there's possibility 2, where it's going to go something like this, right? And it won't clear the fence. So what I would do in this scenario, so this is 30 meters, right? 30 meters. I would find the height after 30 meters. And then I would just see, is it above 6 meters or is it below 6 meters? Because if it's below 6 meters, then obviously it didn't clear the fence. But if it's above 6 meters, then let's say it's up here, for example, then there's no way it would hit the fence, right? It would definitely go just like down over there. So that's what I would do. So let's find out the height at 30 meters. So let's just draw the height equation. So it'll be delta dy equals, and then it's sine 37 times v naught plus, actually this would be minus because gravity's down, right? So 4.9 meters a second squared. And then actually, hold up, I made a mistake here. So v naught times delta t subtract 4.9 delta t squared. Okay. Now there's two unknowns. So there's delta dy and then there's delta t. So you're going to use another equation here, which is delta dx, to solve for delta d, or to solve for delta t. So delta dx is going to equal delta t multiplied by cos 37 degrees times v naught. Right? So if you rearrange v naught in this case, or sorry, yeah, rearrange, so you move this all the way to the other side, then you're going to get 30 divided by cos 37 degrees times v naught, and that would equal delta t. So now you're going to take this entire thing right here and you're going to put it back into this equation. So let's do that now. It's going to be very messy, so I'll skip ahead and kind of put this in. And then also v naught is 25 meters a second, right? Yeah. So v naught's 25 meters a second, so I'll just replace it in here with 25 meters a second. And this is all squared. Okay. So that should be good. And then one thing to note here, so there's v naught over v naught, so you can just, actually, sorry, that's too big here. Yeah, you can just erase these. There we go. Okay, so this is what I have now. And now I should be able to solve for delta dy now. So delta dy, and you just put all these numbers into your calculator. And you should get a number. So I'll just skip ahead to what that will look like. So this is going to be 22.6 and then minus 11.06, which will equal to 11.53 meters. Of course, it's positive as well. So that means at the 30 meter point, it's like this high up. So it definitely crossed it. So we'll say, yes, it crossed it. So here, check mark. Will it clear the fence? Yes. If so, by how much? So what you're just going to do now, you just subtract 6 meters, and so you should get 5.53, around to 5.54 meters above fence. Okay, so let's do the next one. A soccer ball is kicked 40 meters a second. It lands 80 meters away. What angles could it be launched from? So here, I'll just draw this really quick. So soccer ball is launched up like this, lands over here. Let's go 80 meters away. And then, so V naught, the magnitude, is equal to 40 meters a second. So there is a special equation you can use for this. It's called the range equation. So I'll just write it in. Range equals, it's going to be sine 2 theta and then V naught squared over 9.8 seconds squared. Okay. And now what you do next, so we're just going to rearrange. We're trying to find the like theta, right? So we'll just rearrange. So range is 80 meters in this case. So I'll do 80 meters times 9.8 meters a second squared. And then divided by 40, which is squared meters a second. And that is going to equal sine 2 theta. And then you're just going to do inverse sine. And the number you should get after this, so let's just see, what should this equal? So before you do inverse sine, it should be 0.49 equals sine 2 theta. And then inverse sine, so then you just get 29 point equals 2 theta. But now notice how it says 2 theta here, right? So what you have to do next in this case, so there's two options for theta in this case, right? So because if you remember, like if you remember the chart here, right? So sine 2 theta, so that's something like this, right? So if you remember the cast rule, so cast, actually sorry, C-A-S-T. So 29.34, that is like right here, so 29.34, 29.34. Alright, but it's half of that. So it's half of this number right there, divided by 2, and then it's going to be half of this number right there. So what you're going to do, there's two options. So option number 1 is going to be 29.34 divided by 2, and then option number 2, so again, see how this whole thing right here would be 180 degrees, right? But it's not quite 180. It's 180 minus 29.34 divided by 2. So now after you do both these, the numbers you should get are about 14.7 degrees and then 75.3. Yeah, those are the two ones you should get. So equals theta. So theta has two options, and then those are the two numbers you get. So remember this formula. Range equals sine 2 theta times v naught squared divided by 9.8. And then also be able to show this as well. Don't just like memorize this thing right here. You also got to like demonstrate that you know what's happening. Alright, that's all for projectile motion. Alright, here's the next problem. A boat can go 20 meters a second in still water. So that's basically its speed when the water is not moving. The boat wants to go directly east across a river. If there is a current that's going 5 meters a second north, what direction should the boat be pointed? And then there's also a second problem after that, which is if the river is 500 meters wide, how long will it take to cross? So we're trying to find the direction of the boat, like what direction it's pointed in. So let's write all our variables in. So there is the velocity of the boat in water, which we already decided was 25 meters a second. But now we're trying to find the direction of that, right? So theta, that's what we're trying to find. And then there's the velocity of the water with respect to the ground, which we said, the question said was 5 meters a second north. And then the boat's velocity to the ground. Equals, that's actually unknown, but we do know that it's east. So the boat's velocity to the ground, you have to add the boat's velocity to the water, and the water's velocity to the ground to get it right. So I'll just write that in. So boat's velocity to the water plus water's velocity to the ground. Sorry. Actually, no, yeah. Water's velocity to the ground. Okay. Now that being said, this isn't really too important right now because we're just trying to find the direction. So let's draw a little diagram of what this looks like. So we have the boat right here, and then it needs to cross only by going east across, right? But the problem is, when the boat tries to push forward, it's going to get pushed by a current that's going up, right? So it's automatically going to push in this direction. But now the boat needs to cross like right along there, right? The boat needs to go across that way. So it needs to point itself in a direction that's equal to this, downwards, so they cancel out with each other, right? So I'm just gonna, instead of writing it up there, it's gonna be kind of a little bit backwards. Yeah, so I'll write it up here actually. Put it over here. So it's gonna look just a little bit backwards. And then that is gonna be the theta right there. And then we can also fill in for our numbers. So this is going to be the velocity of the boat with the water. It's right there. And then this is the velocity of the water to the ground over there. So let's fill in for that. So this is opposite over hypotenuse. So sine theta equals opposite over hypotenuse. And I'll just fill that in. So 5 over 25 and then so theta should equal 11.5 degrees. So 11 point, I'll just leave all the decimals in because we're going to need this number later. There we go. So yeah, you want the opposite because it needs to cancel out with the push that's up here, right? So it has to go downwards a little bit to cancel out with it. Anyways, that should be the angle you get. And now you're going to want to say also, I guess, the direction, or like how this, it's 11.53 degrees, but it is east. Yeah, so it's east 11.5 degrees south, right? Which all makes sense. And then finally, the second part of the question, if the river is 500 meters wide, how long will it take to cross? So the time it takes to cross, so that's going to be this, like the speed of the boat with respect to the ground multiplied by the time, right? So, or sorry, the distance is, yeah, speed multiplied by velocity. So we'll just do that. So delta D is equal to velocity of the boat with respect to the ground multiplied by delta T, and then you're just going to rearrange. So 500 meters, and we just decided that it was 11.53, so it's going to be cos 11.53, and I'll just do a bunch of dots, and then times 25. So you should get about 20.4 seconds. Okay. And yeah, that's all for this one, I believe. Yeah, that's all for this one. So I'll skip ahead to the next part. So this is a relative motion problem. So here's the problem. Person A runs 10 meters a second north. Person B runs 6 meters a second west, 25 degrees south. What is person A's velocity with respect to person B? If they both start at point P, how long before they are 100 meters apart? So let's do a little drawing of this. So this is going to be person A's velocity. So velocity A. And then there's going to be point P right here. So that's point P, which is kind of like the origin. And then person B runs 6 meters a second west, 25 degrees south, which is something like this. 25 degrees. And that is velocity of B. Actually, let me write that a bit bigger. So we are trying to find velocity of A with respect to B. Now, what is velocity of A with respect to B? Well, you have to remember this point P here. This point P, they're both running away from, right? So velocity of A is actually velocity of A with respect to P. And velocity of B is actually velocity of B with respect to P. So now, velocity of A with respect to B, that is going to be equal to velocity A with respect to P plus velocity of P with respect to B. Now this may seem kind of confusing because what is velocity P with respect to B? We only have velocity B with respect to P. It's a little bit hard to kind of visualize this, but because person B, they're running away from point P, right? So you wouldn't think that point P is running away from point B, but in like actuality, if you think about it, point P relative to point B is moving away from it at the same speed with just an opposite direction. So the velocity of point B with respect to P is equal to the negative of velocity P with respect to B. And if we remember how to do negatives from before, so that's when you take this original thing right here and you just swap west with east and south with north. So P velocity B is just equal to the negative of b velocity p. So it would just be equal to 6 meters a second, and then east 25 degrees north. So if we kind of draw this out now, so velocity of, actually I can just use this right here. So velocity of a with respect to b is going to look something like this. It's going to be that line up there. Okay, so here I'll just kind of draw this in, so I'll make it the pink line. So pink line is going to be this. So now that we know what velocity of p with respect to b is, we can use like our simple math to just figure it out, right? So we'll make the table like we had before. So there's x, and then there's y. Actually, I'll make this a little bit bigger. So, oops. So x, y. So velocity a to p, velocity b to p to b, and then velocity of a to b. Okay. So now let's fill this in. Actually, I'll do a sketch up here as well, just so we can really visualize it. So a to p. Yeah, so there's not really a sketch needed. It's just up like this, and then it's 10 meters a second north, right? Actually, I don't think I've set a direction yet. Yeah, I haven't, so. North and east are positive. Yeah, so in x, it would just be 0, and then 10 meters a second positive. Okay, p with respect to b. So let's see. East 25 degrees north. So that's going to look something like this. 25 degrees. So it'll be sine 25, and this one's going to be positive, times 6. This one is cos 25 times 6, again also positive. And now you would just put these numbers into your calculator, and then of course add this and add this. So these two get added, and these two get added. So this would be 2.5, and so here be 15. Okay, there we go. And now again, you just use. Actually, let me do a quick drawing. So it's going to look something like this. And then that's going to be theta, which kind of matches what we had over here with the pink, right? So pink is the total. So, and then I'll just say, so the magnitude, we'll do Pythagorean's theorem first. Okay, so that is the speed. Meters a second, and then then you can just use tan theta to find to find the direction. So theta equals tan inverse let's see, what did I say was opposite? So 15.43 is opposite. Alright, and then this should equal 81 degrees. It rounds to 81. And then, so, looks like it is north. Actually, yeah, sorry, let me restart this. So, theta equals north 81 degrees east. So let me just put those two things together. So velocity of AB equals 15. I'll say 15.6 meters a second. There we go. And then finally, if they both start at point P, how long before they are 100 meters apart? So this one's pretty simple. You just take the velocity, so you take the distance and you divide by velocity, right? So say delta D equals 100 meters, and they're at the same angle, so you can just take away the angles. 15.6. Which I guess this wouldn't be delta D, but yeah, I'll just say distance. And that's 6.4 seconds. So after 6.4 seconds, they are 100 meters apart. And that is all for this one. All right, so last one, this is proportionality. So for this one, I have a table of values. So there's 5 different x values and then the corresponding y values. And we have to find the equation. So let's just draw a quick little rundown of what this will be. So y is going to equal a k value, and then it's going to be x to the power of something, right? So this n value is what we're going to find first, and then we'll be able to find k right after. So there's a particular formula you can use. I'm going to show how you get the formula later, but the formula, if you really want to see it, you don't have to know how to do it, but it's always nice to know things. So it's log y2 over y1, and this is all over the log of x2 over x1. So now for x2 and x1, these can be any corresponding values here, right? So let's say you picked this as y2, that would be y1. Of course, y2 has to be like later on, and then this is x2. Yes, this would be like x2, this could be like x1. That being said, these two values here that you pick can't make a negative when you divide them. So you couldn't do like this one and this one, because you can't really do that with logs. So it would say it's invalid. So let's just pick the 2 points that I already kind of chose here. So I'm going to fill this in. So n is going to equal log solver. Okay, and now what I'm going to do, I'm going to put these numbers into my calculator just to show what we get. So n is equal to 0.5536 over 0.18452. And then again, just divide those two numbers, and you get roughly 3. It's like 3.0002. And then on your exam or whatever, you would just round to 2, unless your teacher tells you to like be exact. But it's either going to be like 3 or like 3.5 or something like that. Your teacher wouldn't do some weird number like 3.0002 or whatever. So yeah, you just say 3 is the n. And then we also have the k value we need to find. So you're going to fill in n. So you're going to just pick one of these numbers here. I'm going to do I'm going to do this one and this one. So 6.655 equals k. And then what was it? 1.1 to the power of 3. And then yeah, you just divide this and this, right? So 6.655 divided by 1.1 cubed. Let's see what this equals. Yeah, and you get 5. So this equals k, and then k equals 5. Okay, so now about this equation right here. Actually, sorry, yeah, let's put this all together. So y equals 5x to the power of 3. So that's the equation. And then if it was to ask like what's the value at like 4.5 or something, then obviously you just replace x with 4.5 and then solve, right? So let's see how I derive the equation. So I'm going to do y2 equals k times x2 to the power of n. And there's another one, so that's y1 equals k x1 to the power of n. So this is going to be it's going to look a little weird, but this is how you do it, okay? So if you don't know how to do like logarithms or anything, then it's probably going to be pretty confusing. Yeah, so you're just going to divide by k there, and then you're going to take the log of both sides. So log of x squared is n up the top, and then you move to the n to the front, and this is also log. Okay, now in this one over here, you're going to divide, you're going to like bring k just to one side, so it's going to be k equals, I'm just going to say y, I'm not going to say y1, and then x to the power of n. Okay. And then you're going to replace k in here, show what that looks like. So it's going to be log y2 for y1 over x to the power n equals n log x2. Alright. And now what I do next, so this x to the n is gonna come like all the way to the top. That's just how like fractions work, so this is gonna become log y2 over y1. Let me make this bigger. y2 x to the n and y to the power 1. Okay. And now, so you might not have seen this before, but one of the log rules is that a log of like one thing, let's say log of a, so log of a plus log of b is equal to log ab. So we're going to kind of do the reverse of that right now. So I'm going to say log of y2 over y1 and plus log x to the n equals n log x2. Okay, and now you just move this to the other side, and what you should get, so we're almost there, is y2 or y1 equals n log minus, and then I'm bringing the n to the front, so that's why the n's in front there, log x to the 1. And then you just factor out the n, so this is going to become n bracket, and then it's log x2 minus x log 1, so this is going to become log x2 divided by x1, because that's another one of the log rules. So remember, if you subtract them, they become dividing. And then again, you just divide by this, gets divided on both sides, and you will get the formula we had at the start. Equals n. So yeah, that's how you do it. It takes a long time to do. I'm sure there's like a simpler way to derive it, but that's how I would do it. So just remember the formula, because if you don't want to have to derive that on a test, you know. And if you do it different ways, like you could get a whole different answer. And then, anyways, that is the entire review for kinematics. I'm gonna have another one for dynamics coming out soon, and then energy, and then there'll be another one for electromagnetism, and then light later on. So 4 more will be coming out soon. Check the description for the other videos.